Everyone, this is my first assignment for coding assignments. So in this assignment, Professor asked us to modify the functions from the neural network Python file. So first one, we have to modify the evaluate functions, with adding three more functions, like calculation functions, into the net evaluate. So here is my code. Then, so instead of doing just to calculate the accurate account, we are doing to calculate the accuracy from the total networks. So first of all, I just created a output layer using the fat word function from our test set. And also I create the target output from our test sets as well and name as y. So that's how I calculate the correct account from our input value and the output layers. So after I created the total account to calculate the accuracy, so I'm just using the correct account I get from the network divided by the total account. That's how we get the accuracy. So for the three more different functions, we are using the calculation from the class. This is the from for the cross entropy, and this is for the log likelihood, and this is for the mean square error. So I just transform from the calculus equation to the code. Then I'm using NP norm to calculate the mean square error and using the numpy sum to calculate the cross entropy and the same as log likelihood. For overall, this evaluate function gonna give us a list which contains 5 different results. For the second part of the homework, we have to modify the function for SGD. Then, first of all, for this part, I create a empty result set, which the first index gonna waiting for the training data result, and the second index is for the test data result. So for our training set, I called the evaluate function, which we just modified previously. So we're gonna have 5 different results from the evaluate functions. Then I just append the result into the result list we create. After that, I print out all the results for the MSE, the cross entropy, and log likelihood, and also the correct number and also the accuracy. So, which is all the result we get from the evaluated functions. So, same as our test data. So if we have a test data, we're gonna call the evaluate function again, then append the result into the second index for our result list, print out the result. So if we didn't have a test set, so we just append an empty list into our result set. And the last part from this, we just compare the accuracy from the training set to the term percent number, which is 1.0 as original, as default. So if our correct training set is larger than 1.0, then we just break our loop. So as total in the end, we just return the result as a list we create in these functions. After we modify the functions, we create a examples for the training set and the test set. And we call the SGD functions from this data set to evaluate 5 different numbers. That's how we get with only one instance for the training and another for the testing. So secondly, we use the same data set we have, but we instead of doing just one samples, we have more than one samples. So which is have more than one epochs. And also we change our term percentage from 1 to 0.6 and also 0.8. And we're using different data set now. And the same as before, we create a different term percentage for 0.6 and 0.8 as well. And we change the eta number, the epochs number as well. So change from 100 epochs to the 125. So in the end, we have for two different results as the graph. One, we can see the MSE has the lowest number, so we create another graph to compare the result for the MSE for the training and the test.